Okay. So what are the types of data that you have? Okay, we need to understand what kinds of data we have, because the kinds of data we have will determine what kinds of analysis we can do. Right? We can do. It doesn't mean what kinds of analysis you should do. Is not just based on the types of data, but it's based on your problems. Okay. Recall that we have two types of data in terms of the methods that we collect them. The first is primary data. Okay. Primary data is directly collected from the original source. Okay. The data elements are collected using techniques tailored to the specific purposes of the study conducted. Okay. For example, so what are original sources? We want to understand tourists, so we do a survey of tourists. We get information about them, we get data, we get their profiles directly from them through a survey, through an interview, through observation. You can stand in the airport and have a clicker and count them. That's primary data collection. You do your interview with experts, you're getting their insights, their answers to your questions directly from them, the original or primary source. Okay. And you're getting the data from them based on the specific purposes or objectives of your study. Okay, so you can design your tools or your questions for collecting those data from your sources to respond directly to your research objectives or purposes. Secondary data is data gathered typically by someone else for a purpose other than the study for which they will be used. Okay. For example, you might collect data from the Department of Tourism on visitor arrivals to a particular destination, because you need those statistics to make some kind of analysis or conclusion about that destination given your own research problem. But DOT, or the local government which collected that data for DOT, collected those visitor arrival statistics and profiles of their visitors for their own purposes. Their research objectives might be or are probably going to be very different or from your own. Okay, so while the secondary data might be relevant and still useful to your study, okay, they may not fully or directly answer all of your data requirements. Okay. So that in that sense, they're more difficult to use and more difficult to interpret, because the purposes for which the secondary data was collected is very different from yours. Okay. So we have, in terms of level of measurement, we have two main groups of data. Okay. Categorical data and quantitative or metric data. Quantitative data represent qualities or characteristics that can be used to group persons or objects according to similar characteristics. Okay. And we have two types, nominal and ordinal data. Quantitative data is data that is measured using a numerical scale that reflects a quantity. And again, we have two types of metric data or quantitative data, interval and ratio. Categorical data, again, represents qualities or characteristics that can be used to categorize a person or object. Okay, so for example, a person has certain characteristics, can be described in terms of sex, age, occupation, educational purpose, etc. Okay, and then we can group people according to these characteristics. Okay, so the first type of categorical data is nominal data. Okay. So nominal data has the characteristic that it can be counted. Okay, people can or our subjects can be counted according to those characteristics, but they cannot be arranged from lowest to highest. So for example, our respondents, we can arrange them, we can count them in terms of sex. Okay, how many of our respondents are male? How many of our respondents are female? How many of our respondents refuse to answer? Okay, so we can have three groups of respondents: males, females, refuse to answer. Okay, but we cannot arrange the values. Okay, we're not talking about the counts. Like, we're not talking about how many males, how many females, how many refuse to answer. We're talking about male as a value, female as a value, refuse to answer as a value. Okay, there is no logical system for saying that the answer of male has a higher value than female, or a higher value than refuse to answer. When we put them on a list, we can arrange them in any way we want. We can arrange them alphabetically. We can arrange them randomly. We can always put refuse to answer at the bottom, but there's no difference in the value between those possible answers. Okay, so nominal means nominal data can only be counted. We can say how many exactly, how many males, how many females, how many did refuse to answer. And if we can count them, we can also get percentages. Right? What percentage of respondents were male, what percentage of respondents were female, and what percentage of our respondents refused to answer. Okay? That's all that we can do. Okay? So other examples of nominal data, for example, nationality: Filipinos, American, Chinese, etc. Occupation: student, doctor, professional, unemployed, etc. Okay, these are all groups by occupation, but there is no arranging them from lowest to highest. Okay, it doesn't matter. Ordinal data like nominal, can be counted. Right? Ordinal data can be used to group people according to their responses to that item. The difference is that when we group them into these response categories, we can arrange those categories from lowest to highest, or vice versa. Okay? For example, we can arrange our respondents by age group. Okay, 18 to 25, 26 to 30, 31 to 35, 36 to 40, etc. Okay? But we can in contrast to nominal data, we can see that the categories represent a range, which can be organized from lowest to highest. 18 to 25 age group, talking about age, number of years, is lower than the age group of 26 to 30, which is lower than 31 to 35, which is lower than 36 to 40. Okay. But then at the end we have 60 above 65. Okay, so so ordinal data, like nominal, can be counted. They're categories, but the distances between the categories are not equal. Okay, so as I said, examples are age group, educational attainment. Okay, elementary, high school, college, postgraduate, etc. There's also a question format called a Likert type scale. So for example, if I were to do a survey and I were to ask you, to what extent do you agree with the government's policies on quarantine during COVID? Okay? Answer 1 if you strongly disagree, 2 if you agree, 3 if you neither agree nor disagree, 4 is agree, and 5 is strongly agree. Okay, so it goes from strongly disagree to strongly agree. Okay, As you go from 1 to 5, your level of agreement increases. Okay? As you go from 5 to 1, your level of agreement decreases, or your level of disagreement increases. Okay? But let's say one person writes in response with number 1, strongly disagree. Okay? Another person answers 2, which is agree. Okay? And then I answer 3 because I do not disagree, but I'm also not sure if I agree. So I put in 3. Okay? So the person who wrote number 2 clearly agrees more with the policy than the person who strongly disagrees. Okay? Right? So because he or she is only disagrees, but it's not very intense. The first one is strongly disagrees. Okay, so their level of agreement is different. Okay, I'm neutral. Okay, but I don't disagree as much as number 2. Okay, or in other words, I agree. My level of agreement with the policy is a little higher than the person who answered number 2. Okay, so you can see that we can be arranged 1, 2, 3. But is the difference in the level of agreement, okay, or disagreement, okay, between me who wrote number 3, who answered 3, and the person who answered 2? Is the difference in our agreement or disagreement exactly the same as the difference in agreement or disagreement between person who wrote 2 and the person who answers 1? There's no way of knowing exactly that, because respondents interpret, okay, strongly the differences between strongly disagree, neutral, agreed, strongly agree, in their own ways. I might consider that the two choices are very widespread, and then others might consider that the differences are very small. Okay. So we can't say for sure. That's why we say that kind of question is ordinal. Okay. So, and now we'll get into illustrating the difference now between ordinal data and quantitative data, which is data measured using a numerical scale that reflects a quantity. And you might interpret that phrase of reflecting a quantity as having intervals that are clearly equal. Okay, so interval data can be arranged into an array, meaning from lowest to highest or highest to lowest, okay, where the distances this time, or the intervals between the categories, are equal. So for example, if I ask you about age, not age group, what is your age or how old are you? Okay, and people answer 26, 25, 24, 35, 38, 50, etc. Okay, that you can answer in any way that you want in terms of, and the possible answers are by years. Okay, when we say that the categories are equal, that means the difference between a 26-year-old and a 25-year-old is exactly the same as the difference between a 100-year-old person and a 99-year-old person. The interval of 1 year is the same. They're all 365 days in a year, and we will forget about leap year for our purposes. Okay. Similarly, if you're measuring temperature, whether it's in Celsius or Fahrenheit, okay, they're all in terms of 1 degree. Okay, so the difference between 49 degrees Celsius and 48 degrees Celsius is exactly the same as 83 degrees Celsius and 82 degrees Celsius. As long as you are comparing similar scales. You can't compare Celsius and Fahrenheit, by the way. Okay. So that's interval data. Ratio data has exactly the same properties as interval data. but it has a true zero value, where if you answer 0, that represents the absence of the element or characteristic being measured. Okay? So for example, if I ask you, what was your income in 2019? If you answered 0, that means you literally had no income for 2019. It reflects the absence of income, the characteristic being measured for 2019. Exam scores. Okay, your scores will show how many questions you answered correctly. Okay, the total number of correct answers. If your exam score is 0, that reflects the absence of correct answers in your exam. Okay, so that is what a ratio. That is what the ratio level of measurement means. Okay, to have a true zero value. Now we've talked about 4 types of data, and they're also called 4 levels of measurement: nominal, ordinal, interval, and ratio. They're called levels of measurement because you can go from lowest to highest. And as you go down from nominal, ordinal, or higher, as you go up from nominal to ordinal to interval to ratio, okay, the next level of measurement, okay, contains all the characteristics of the level before it, plus a unique characteristic. Okay, so let's review. Nominal data can be counted. Okay, that's one. That's the only characteristic of nominal data. Ordinal data can be counted, but it can also be arranged from lowest to highest or highest to lowest. Interval data can be counted, can be arranged into an array from lowest to highest or vice versa. And then its unique characteristic is that the distances or the intervals between each possible answer are equal. And finally, the highest level of measurement is ratio. It can be counted, it can be arranged from lowest to highest. The distances between the possible answers are equal. And finally, it has a true zero value. So interval and ratio data, because they have numerical value, they reflect true quantities. These are the only data that we can correctly apply mathematical operations on. Okay, we can add, we can subtract, we can divide, we can multiply, we can do any kind of mathematical operation, and therefore any kind of statistical operation on these kinds of data. Okay, for categorical data, generally we can only count. We can have percentages, and that's it. Okay, generally. Later, when we get into statistical analysis, we can show that there are some statistical techniques which use non-parametric statistics to get around the limitations of nominal and ordinal data. Okay, so in our next for the next lecture, I'm going to use an example of an actual concrete examples of these kinds of data, and then also how to prepare the data for analysis. Thank you.